Welcome to another OpenStack and container integration video. Today I want to talk about Tripleo and the integration work that has gone into actually making it possible to use containers within Tripleo. First, I want to provide some background for the demonstration. So Tripleo is split into two pieces, the undercloud and the overcloud. The undercloud is going to be the deployment cloud that you are going to use to deploy the overcloud, which is the user cloud. In this demonstration, I'm going to show the containerized overcloud deployment that comes spawned from a standard undercloud deployment. Currently, my setup is I've already deployed the undercloud, and what I'm going to do is I'm going to just use it to deploy my containerized overcloud. And so I'll start by running through this here. And so first we're going to look into Glance because I want to highlight that we actually have a rel atomic image. And that's what we're going to use for our setup is atomic. All these containers are going to be spawned in atomic. For this to be available, we will make it add support for Fedora Atomic so other people can use it. But right now, that's for this purpose of demonstration, we're actually using rel atomic. Okay, so we're going to look at the Nova flavor list, and you can see that there's a bare metal flavor. That comes standard with the undercloud setup. And you do a heat stack list, and I'll show you that there's nothing, in fact, running. So next we're going to actually I'm going to run this script that we have set up, and I'm going to show you exactly what that is in just a second. So we're just going to run that script. Our heat template's going to be, our heat stack's going to be called overcloud containers, and we're actually going to cat that heat start script, and you can see right there that in fact this is actually just a really simple heat stack create command. It's pretty standard. But instead of actually calling the overcloud resource registry, we're going to call the overcloud resource registry Docker. So this is slightly different because normally that would be actually Puppet, but we're going to do Docker in this case, specific to the containers. It's slightly different. Okay, so now we're going to look into the heat resource list just to show that there's something happening here. And we're going to actually spawn, in this case, we're going to spawn 2 compute nodes and a controller node. So you can actually see here, controller is create in progress. And so we're going to follow that. Actually, we're going to let it run while we do that, we're going to look into the install Docker agents, which is basically a heat hook that allows us to communicate, use heat to communicate with Docker so that we can spawn our images from a heat template, which I'll show you right here, how we specify the atomic image from the outside, and the command it's going to run is actually an atomic install, and the atomic install is really is basically like a wrapper around a Docker run with essentially the proper parameters that we need, like volume mounts and etc., to actually start these containers properly so that they'll actually work. Okay, so we're going to do a Nova list right now, so you can see that there is an instance spawning. So we'll skip ahead, and you'll see that there we go, that's active. So that is the controller node that's going to come up first because the compute nodes are actually dependent on the controller node. And the reason for that is just so that the containers will spawn properly. We need the controller node first because Keystone is going to be on the controller, and we don't want, well, compute can be up first, but they'll just be hanging out and just kind of waiting for Keystone. So we might as well let Keystone spawn first. Draw your attention to the heat Docker atomic agents container. That is going to be essentially going to be communicating with heat so that we can run the containers. So you're going to cat entity release here, and you'll see that we actually are in fact running on atomic. And we're going to start looking at the Docker images. You can see there's already one coming down right now, and they're going to come down really quickly. So here comes the rest of them. This is the registry, the API, the Glance registry, Glance API, and there's some more coming, possibly Keystone next. Okay, there we go. So you can see that they are in fact starting. And right now they're actually in our starting state because these containers are designed to continue to restart until like specifically Keystone is ready. So Glance is going to continue to spin until it finds Keystone ready. So we're going to actually watch that happen. So and Keystone actually even waits for MariaDB. So MariaDB is up. Now you're going to see them all just start to come up. So Keystone found MariaDB. Now it's running. The Glance API and registry should be next. There's the API because it's able to talk to Keystone. Now the API is up, so now the registry should be able to find the API and Keystone, and there we go. So now all the containers are up on our controller node. Okay, so now we're gonna actually check out the logs for Keystone because I just wanted to show that how this is possible, what it's actually spitting back out at us. And this is kind of a standard log from one Kolla containers that a Keystone Kolla container is that there's some basically we're gonna create the the admin user role, basic Keystone setup to really get the service running, create the endpoints, etc. Okay, so now we're going to look, and you'll see that everything is now running. There's no conductor, no API. Everything is up and going on the controller side. Okay, so we backed out of the controller container. Now we are going to show the resource list for heat right now, and you can see that the controller is in fact complete, and right now the compute nodes are starting to spawn. They're building. Let's just take a moment. They're just starting to go, and there we go. Now they're complete. Okay, so now we're all set. Our overcloud is now complete. As seen with the heat stack list right there. So now I just want to do an output show of that overcloud containers because this is actually going to show where we've the location of Keystone. So this is important because compute nodes need to talk basically to the controller in order to find Keystone, Rabbit, MariaDB. It needs a location of that, and because I'm going to use the that network for those to look for to put MariaDB and Keystone on, then it'll allow for Nova to communicate on that IP. So I'm actually going to I'm going to generate my credentials, and I'm actually going to cat that, and to show that those are my credentials right now, so you can see where those in fact come from, and that essentially comes from the output of the heat output show. That's where the author URL and the credentials all come from. And so we're going to source that, and we're going to start running some things. We're going to do a Keystone user list, and you can see how the services are actually here and registered within Keystone. Glance, Keystone, and Nova are all here, and so we'll all start using them. So we'll do a glance image list. So you got nothing running right now. Do a Nova list. We got nothing running right now. So let's try and make something happen. Let's spawn. Let's put an image into Glance here. I already downloaded a Ceros image, but let's just push it right into Glance to show that you can in fact do that. Okay, so that loaded into Glance just fine. Now we're going to actually boot an instance from that image. Okay, so we'll do a Nova list here, and you can see that it's in building state right now. So should be just another moment, and we'll see it actually go to active state. So there you go. Now you can see from this demonstration that Tripleo and containers are actually becoming a reality. That this development process so far has been very successful into actually integrating containers into Tripleo so that the user in the overclock can actually experience containers and their services running containers and really get all the benefits of using it. So these containers are actually stock Kolla containers. You can actually check out the Kolla project that actually is the container medium for these specific OpenStack containers, and they're actually just have an atomic wrapper around it. So this is actually very basic, just so that they run a little more smoothly on atomic. So all this work is soon to be published, and actually there's a bunch of patches up for it to be merged probably very soon that will actually allow other people to use it, try it out, test it themselves, and just have fun with it and to really develop this technology. So thank you for watching. I'm Ryan Hallisey, and you can follow me on Twitter. I'm Ryan Hallisey1, and you can look forward to more videos that will be coming out following this one.